Hello and welcome back to another video. In this poem, we're asked to show by means of an example that the limit as x approaches a of f of x plus g of x may exist even though neither the limit as x approaches a of f of x nor g of x exists individually. So our example, a is going to be equal to 0, f of x is going to be equal to 1 over x, and g of x is going to be equal to negative 1 over x. So we are saying that the limit as x approaches 0 of f of x plus g of x exists. This is the limit as x approaches 0 of 1 over x plus negative 1 over x is minus 1 over x. This is the limit as x approaches 0 of 1 over x minus 1 over x is 0. The limit of 0 at any value of x is just 0. So this limit does exist, it has a value of 0. However, the limit as x approaches 0 of f of x, right, the limit of 1 over x does not exist. So if we think about it, as this number gets smaller and smaller, the fraction is going to go off to infinity or negative infinity. And the reason this function does not exist is not because of that, right? If a limit goes off to infinity, that's still a limit. However, if we're approaching 0 from the right, it's going to go off to infinity. These are numbers that are slightly greater than 0. So this is positive divided by positive, it's going to be infinity. Here, from less than 0, these are values that are negative because they're slightly less than 0. So this is a positive number divided by a negative number. So even though the magnitude is still going off to infinity, because this is 1 divided by a very small number, it's positive divided by negative, so it's negative infinity. From the left and the right, they don't match. Therefore, the function does not exist, right? And the limit of negative 1 over x does not exist, right? I guess this would be g of x. This does not exist because this is just adding a negative sign to both of these, and they just swap places. This one becomes negative infinity, this one becomes positive infinity. Therefore, the limit as x approaches 0 of f of x and the limit as x approaches 0 of g of x do not exist, right? In one direction it goes up to negative infinity, in the other it goes up to positive. However, the limit as x approaches 0 of their sum, f of x plus g of x, does exist. And it equals 0.